Hello friends, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecule. Today's topic of discussion is a very interesting topic, green hydrogen. It is a part of renewable energy. So a lot of knowledge you will get in this video. So please watch until the end. So let's start our video. So this is actually a fuel or chemical both for green energy as well as sustainable future. Because we need to take care of our planet if we want to have a better life. But before going to details, one MCQ for you. I request you student, please pause the video, try by yourself. It's a very easy question, and whatever answer you get, please write in the comment box along with few words if you know about its explanation. You will get the right answer at the end of this video. Now let's start the main topic. In the video I told green hydrogen. So a simple, very common question may come in our mind. Does hydrogen has any color? Because I am telling green hydrogen. Actually, the answer is no. Hydrogen doesn't have its color. Hydrogen is colorless, odorless, tasteless in nature. It doesn't help anyone to burn, but it gets burned in oxygen atmosphere in a blue flame. What is green hydrogen then? The term green hydrogen appears on its method of preparation, how it's prepared. Actually, if it is produced from renewable energy sources, which has a very low carbon footprint, so actually you may consider it's a very safe method to prepare hydrogen. This way the energy we are harvesting, and this energy mainly, if I say it's electrical energy, is utilized for the electrolysis of water into hydrogen and oxygen. By the way, the word electrolysis, what does it mean? Electro means electricity, lysis means breaking. So you can say breaking of chemical bonds in water molecule by the energy produced from renewable sources results this green hydrogen, along with obviously oxygen as byproduct. And for that purpose DC current is needed. Also, I request you student remember this point. There are two kinds of hydrogen which closest to green hydrogen. So here pink hydrogen, actually it's a closer to green hydrogen, but it is made via also electrolysis, but here the electricity is produced from nuclear energy as a source of power. So you may consider, previously we talked renewable electricity, renewable energy is utilized to make green hydrogen. In this case, nuclear energy is utilized to prepare this pink hydrogen. Not only that, there is a similar word, yellow hydrogen. What does it mean? In this case, the electricity is actually solar electricity. So whatever mainly we focus, okay, solar cell, etc., we are producing energy. If you produce your energy directly from solar cell, that is yellow hydrogen. If you produce from solar cell as well as other renewable energy sources, that is green hydrogen. Okay, for example, if you say renewable energy like solar, wind, hydro, etc. Next, application of this green hydrogen. Because we understand that green hydrogen could be prepared very efficiently by electrolysis, but its utilization is also needed. Actually, mainly three types of utilization we will discuss. First, electricity generation. So you may ask one question, sir, what is the need of generating electricity? Green hydrogen means actually you use solar panel to produce electricity from sunlight. Then you are producing hydrogen again. Again you are generating electricity from that hydrogen. What is the need? This is because solar electricity is not available for 24 hours because sun is not available for 24 hours. So in daytime you use the solar electricity, and using the extra solar electricity produced, you can produce this green hydrogen by electrolysis. Later on, this hydrogen could be utilized in the fuel cell with pure oxygen or air. Actually, oxygen is actually reacting. You can use pure oxygen or air as a source of oxygen to produce water. Is a byproduct and electricity. So when it's needed, so it is one of the purpose. And in this case, the setup is used, which is fuel cell. Fuel cell is actually a electrochemical cell that converts chemical energy of a fuel, of an hydrogen, or there are other fuel cells also like methanol fuel cell or another oxidizing agent, and often it is oxygen, into electricity through a pair of redox reactions. So you can understand redox chemistry is utilized in fuel cell to generate electricity. and you can see a typical image of a fuel cell. More specifically, if I say it's a hydrogen fuel cell. So here you see air is going inside, which is carrying oxygen. These oxygen enters into the electrolyte chamber and unused oxygen gas comes out. You make obviously take the fuel in, what, hydrogen, and these hydrogen also goes to the electrolyte chamber, reacts together and produces water. So hydrogen and oxygen react together, produces water. By the way, remember, water is actually a very stable molecule compared to hydrogen and oxygen. That's why, because of these reaction, huge amount of energy is produced. This reaction is actually exothermic, it produces energy, and fuel cell is a setup which converts this energy into electric current. So as a output of the fuel cell, we get electric current. So in this way, this energy is converted into electrical energy. Okay, now overall energy cycle, if you say that in daytime, extra renewable energy you can utilize to break this water. By the way, why I am telling the word extra? Because you need to first fulfill the local demand. After that, whatever extra is there, you need to store that energy into some form. That's the main purpose. So here, whatever energy extra produced, that energy is consumed to do the electrolysis of water into hydrogen and oxygen, and these are actually, student, their fuel. So it means energy is stored in this molecule. So whenever you need the extra energy, mainly night time, so you can react these two in the fuel cell and produce the electrical energy, and in this way you get your water back. By the way, when we do any kind of energy production, we need to think, okay, source, raw material. But here raw material is water, byproduct is also water. We have a plentiful of water in this world, so it doesn't matter. And if I say solar electricity, we have huge. By the way, I have already discussed a dedicated lecture, that is one sun, one world, one grid. That's a very big or ambitious project to harness solar electricity globally. You may visit. Now, so why hydrogen is so important that we are focusing too much on it? Because of its maximum energy output with respect to per kilogram of fuel. For example, 1 kilogram of hydrogen produces nearly 39.4 kilowatt hour energy. Compared to look at diesel 12.7, petrol 12.9, natural gas 14.7, coal 8.2, even if you look at jet fuel 11.9. And by the way, you can see Tesla battery. What does it mean? This is lithium ion battery. It is provided here, but I will not say it's not a completely comparable, because all these fuels, they are consumed, but lithium ion battery is recyclable, reusable. But a comparison, that energy density of lithium ion battery versus hydrogen, it's a tremendous energy density. By the way, I have not included one option, that is nuclear. Nuclear fuels energy production is far more higher, but lots of safety issue are there along with nuclear. So it is better to focus on renewable sources rather than nuclear solely. So here this hydrogen bond with oxygen and produce energy, that is the main thing. Now next, the point number 2 regarding the uses of green hydrogen, that is fertilizer production, mainly urea production. By the way, student, urea is the most used synthetic nitrogen fertilizer. Okay, and how urea is prepared? First, ammonia is prepared by Haber process or Haber-Bosch process, where nitrogen, obviously it is isolated from air, reacted with hydrogen, which produces ammonia. By the way, these hydrogen we are talking to be replaced with green hydrogen. Right now, from where this hydrogen comes, it comes from either petroleum or mainly it comes from natural gas. But these natural gas to hydrogen production also are carbon dioxide emissions. So you may say it's a carbon footprint there. And these produced ammonia is utilizing the next step for urea preparation, where it reacts with carbon dioxide at high temperature, high pressure, produces this urea. By the way, this urea preparation process contributes nearly 1 to 2% global CO2 emission. I know you'll be surprised, sir, 1 to 2%, only urea? Yes. 50% of our current population is surviving because of these molecule only. So this is the remarkable process. And by the way, remember this Haber process is associated with high pressure as well as high temperature and Fe2O3 iron oxide as a catalyst. So it's a very important use of green hydrogen if we can do it properly. And the third point of green hydrogen is zero emission transport, because remember student, transport sector emits huge amount of carbon dioxide annually throughout the globe. So if we want to make our transport clean, then we need to use these hydrogen based fuel cell car. By the way, we'll say, sir, there is battery car. I agree. Remember, we shouldn't depend on only one source completely. We should focus on different sources for our transport sector. That is better for a sustainable transport sector. Now here this hydrogen stored in the fuel tank, and it's actually responsible for the supply of the energy, because in fuel cell when this hydrogen burn, it produces electricity, and that powers the electric motor which pulls this car in front. So you can see here there is a Toyota model fuel cell car. Not only Toyota, lots of famous car companies are nowadays producing their hydrogen based car, mainly fuel cell powered vehicles, car where hydrogen produces electricity in the fuel cell. So in conclusion, what you have learned today, that hydrogen is a clean combustion fuel, and currently it is produced mainly from natural gas or petroleum, which has a carbon footprint. So if this hydrogen we can produce from renewable sources, it is very good energy option against global warming and climate change. Not only as an energy option, we can utilize this hydrogen in the chemical industry too, fertilizer preparation, even lots of other chemical reaction too. For example, petroleum cracking, etc. But our target should be completely eliminate this liquid fuel in future. Now next, second point is hydrogen has maximum energy density, I have told, with respect to per kg compared to all traditional fuel except the nuclear energy. Third point, the green hydrogen could be an option for chemical energy storage of the extra renewable energy produced during the daytime, because solar is not available for 24 hours. Even all renewable energy sources are not completely regular, their supply is not regular. So we need to keep backup, like those renewable energy could be stored in some form, and hydrogen's preparation is like a chemical energy storage. And these green hydrogen could be utilized in electricity generation, transportation, fertilizer, even steel production. So this much application these hydrogen fuel has. Now what is India's step? Because our Prime Minister proposed that within 2070 India is planning to be carbon neutral. So lots of important steps needed at it, as India is nearly 140 crore population. So for that purpose, government plans rupees 17,000 crore incentive scheme for electrolyzer, which will produce green hydrogen mainly from solar electricity. So this is India's step. Lots of project will come, even in India. Reliance Industry as well as Adani Group, they are also planning on focusing on this green clean fuel. So let's come back to our MCQ. How many isotopes are obtained for hydrogen atom? Actually for hydrogen there are 3 isotopes. Common hydrogen, it's called protium. There is another heavy hydrogen which sometimes written as H12 deuterium, or sometimes it is written in this way also 12, any one of them. And another hydrogen is there which is called tritium or radioactive hydrogen. It is also represented any one of these way. So protium, deuterium and tritium, 3 types of hydrogens are there. So that's why option C will be the right answer. So this is the overall discussion for today's video. Thanks for watching. See you in my next video. Bye bye.